Welcome to another episode of Science Made Simple. I'm Dr. Ryan, and I'm a science specialist here at the Pique Lab. In this video, I'll be analyzing a past year examination question on the topic of energy changes. I've also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started.
Let us look at this question. A rocket can be fueled by hydrazine burning with excess dinitrogen tetroxide. The reaction in the rocket engine is shown in the following diagram and equation. If you were to analyze this equation, you will notice that the first species is hydrazine, whereas the second species is dinitrogen tetroxide. Which of the following takes place in the rocket engine? Statement 1. The oxygen state of nitrogen increased from -2 in hydrazine to 0 in nitrogen. Let us examine the oxygen state of the elements in the reactants as well as the products. So first, for hydrazine, it contains nitrogen and hydrogen. And if you can recall, the oxidation state of hydrogen in most compounds is +1. So it is +1 here and here, with the exception of metal hydrides. One example of metal hydride is sodium hydride. And in sodium hydride, the oxygen state of Na is +1, whereas the oxygen state of hydrogen is -1. Besides this, hydrazine also contains nitrogen. So the oxygen state of nitrogen, if you were to work it out, it will be -2. And this is in accordance to the rule which we have learned in redox, whereby the oxygen states of all atoms in the compound must add up to the overall charge. So for this case, we have 2 nitrogen with the charge of -2 and 4 hydrogen with charge of +1. So overall, these will add up to the overall charge of hydrazine, which is 0. Next, let's look at dinitrogen tetroxide. Dinitrogen tetroxide is made of nitrogen and oxygen, and if you can remember, the oxidation state of oxygen in most compounds is -2. So it will be -2 here and here. Of course, there is an exception, and the exception are for peroxides. One example of peroxide is H2O2, known as hydrogen peroxide. So in H2O2, the oxygen state of hydrogen is +1, whereas the oxygen state of oxygen is actually -1. Now, by applying the same rule that we have seen over here just now, you will know that the oxygen state of nitrogen is +4. And if you look at the right-hand side, we are left with N2. And the general rule of thumb is that the oxygen state of an element is 0. Therefore, nitrogen has an oxygen state of 0. And if we were to analyze the change in oxygen state of nitrogen, we will notice that nitrogen's oxidation state changed from -2 in hydrazine to 0 in nitrogen. So in fact, from -2 to 0, this is in fact an oxidation reaction. Therefore, statement 1 will be correct. Besides this, let's analyze what is being reduced. Now, if you were to analyze the same equation above, you will notice that amongst all the elements, this nitrogen over here is actually being reduced. So it is reduced from +4 to 0. So this is a reduction reaction. Interestingly, for this question, you have 2 identical elements, one being oxidized and one being reduced to the same product. So for such type of reaction, it is actually known as comproportionation reaction. Let's examine option 2. 3.5 moles of gaseous products were produced when 1 mole of hydrazine is used. Now, if you were to analyze the equation on top, you can see that for the left-hand side, we have 2 mole of N2H4, whereas on the right-hand side, we have a total of 7 mole of gaseous product. This means that the mole ratio of the gaseous products to hydrazine will be 7:2. And if you were to simplify it, it will be 3.5:1, which makes this statement correct. And let's look at the last statement. Endothermic reaction occurs. Now, the question actually gave you a big hint over here, which is the word burning. Now, if you can recall what you have learned in your energy changes, this burning actually implies combustion. And for all combustion reactions, for example, when we combust methane or we combust any fuel, we obtain energy from it. So in fact, for all combustion reactions, they are exothermic reactions, which means they release heat. Therefore, this means that statement 3 is incorrect. With this in mind, you will know that option 2 will be the answer.
Thank you for watching, and I hope you have enjoyed this video. If you found this video useful, do give us a thumbs up. If you'd like to check out more videos by us, Do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. Thank you, and I'll see you next time. Bye!